The question is, what are the equations of equilibrium for rigid body? Look at this question 3AI. Okay, you're told to what? Write the equation of equilibrium of rigid body. The answer is this. You can start writing it like this. That the equation of equilibrium that is the equation of equilibrium for a rigid body are three scalar equation that must be satisfied for a body to remain in equilibrium. Full stop. Can I say the equation? Therefore, the equation. This equation are summation fx. I mean, in the x direction now. Let me see in the x direction, or you can call it in the x direction or horizontal direction. Summation fx, that is the sum of forces in x direction, will be equals to 0. That is number one. While secondly, in the y direction, that's vertical. In the y direction, that's vertical, it will be equals to summation, that is the sum of force along y will also be equals to 0. And thirdly, because there are three, and thirdly, that is the sum of moment or torque. Can say the sum of moment or torque, that is sum of moment or torque about any point will be equals to 0 also. That is the answer. What is a free body diagram in mechanics? We say, what is a free body diagram in mechanics? Okay, let me start this way. Free body diagram. The definition for free body diagram. Some call it force diagram, but let's start with free body diagram. Free body diagram is just this is a sketch. This is a sketch of an object. A sketch of an object of interest with all the surrounding objects, they are stripped away, and all of the forces acting on the body show, and all of the forces acting on the body shown. All of the body acting in the body were shown. This is what I mean by that. You see, a V-body diagram is just a sketch of an object, of interest with all the surrounding objects stripped away. They are all stripped away, and all of the forces acting on the body, and all of the body acting on the body are shown. They were shown. You can see them, that they were what? They were shown. You can see them. And the body shown. Okay, this is what I'm trying to bring out. You see, in an environment now, you see, for you to maybe carry a load now, I guess I'm saying, there is let me say an object. You were to carry the object, but let me tell you, there is something we call interest in carrying something. When you want to carry that thing, if there is free body diagram acting on it with all the surrounding objects stripped away, that is, there are the surroundings object also with that load you want to carry, and if the free body diagram act on it, there's possibility of you seeing all the forces acting on that same object or load that you want to carry. That's just it. An example of free body diagram, let me use one example. You can see of a spare. When you look at a spare, you know that our spell, spell and SPHERE, spell. Example, that is spear. Okay, let me say a spear resting on plain surface, spear with arrow be acting upward. This is what I'm trying to say. You see, when the spear is resting on a plane or a surface plane, you see, there is what we called a weight. Spear also has a weight, but the plane is what is carrying it. But when a free body diagram act on it, we see the force acting on that spear, because spear is also acting as a load, and that is why we use spear as example. That is just it. We were told in the question 3AII that we should state the two procedure for drawing what? Free body diagram. One thing about this is that I have 3 things here, and it should be okay for you to know how to draw a free body diagram. Number one is that you select the object you would like to study. Secondly, you draw a picture of the object. You draw a picture of the object of interest free from all other objects. And thirdly, we are only asked to, but this is the third one I put there, you indicate on the diagram all interactions of the body of the object with its environment or surrounding. These are all the theory procedures for drawing free body diagram. Looking at this question now, this question 4, we're told that two smooth tubes A and B, each having mass of 2 kg, rest between the inclined plates as shown. Draw the free body for tube A and tube B and tube A and B. Okay, for me to do this one now, we are told to draw the free body diagram for what? For each tube and for the both. Okay, this is what I'm going to do now. If I want to draw what? The free body diagram of this thing that was given. Okay, here's how I'm going to draw it. Okay, looking at this now, for tube A now, solution for tube A, I'm going to have something like this. Tube A will look like this, and that's what I will be having. I will be having something like this and like this, which has been as the draw it there, and this one is our A. Now we are going to have a force acting that way, because I told you that when it's just when you know the definition of a free body diagram is when it acts on an object, it take away the surrounding object and the force acting on it was seen. You see, the force acting here is that, in the question we were given what? 2 kg. If you look at the very, we were given 2 kg rest between the inclined plane. That is 2 kg rest. That will be 2 kg here, and that will be 2 times 9.81. 9.81, that's 19. It will give you 19.62 Newton. 19.62 Newton. And if this one is 19.6 Newton, you see there is a acting angle here. The acting angle was around here, and we have the force, the effect, and we have what we call the effect of slope for acting on A. That is F here, and there is an angle here. The angle here is 20 degree. You can call it 20 degree, and that's it. You can call it 20 degree, and the R is acting here also, and it is what? This one is 20. We have 20 degree. This one also have 20 degree angle here, and there is also a tension here. We have a tension. This is a tension. This is a tension. You can say this tension also is acting with 20 degree. Why for B now? This time around, if it is for B, it is also the same thing. You will just draw it this way for your B, and there is a small circle inside. Also, you now have only R and P. You now have the R and P will be the one that you have here. You now have your, that is force P will be the one acting now. Force P, they will now be acting downward. This is just the analogy. This is it. This is how it will look like. This is how it will look like. And this one is 19.62. This place is my R P, and maybe the line that's drawn here. This place is 20, and we have 19.62 Newton. This one is for what? Tube B. This is tube A. For both tube now, let me draw for both tube. I mean tube. We can also have for tube A and B. A and B. A and B. Tube A and B now. For tube A and B, should just be something like this. It's like you redrawing this back. Okay, let me just draw the thing back to A, and let me draw it like this to A, to A. You redraw the thing back to A, to A and B. You have your first cycle here, which is your A, and you have your second cycle here joining with this guy here. And your small cycle inside. This is your A, this is your B. Okay, you now have 20 degree. There's 20 degree here. That is your final answer. You have gotten it. This is just it for the two, A and B, and the free body diagram. This is just the answer, and you can have your full mark. Thank you. God bless you for that. If you draw it this way, you are going to have your full mark, and that's your answer. And this place will have P. It will have RP. That's just it. The question is, a beam is supported. There is a beam that was supported at both ends as shown below. We were told to determine the reaction at A and B. Neglect the weight of the beam. That is, we were told to neglect the weight of the beam, and this is what we are going to do. That will be summation H. That is, the summation of the horizontal will be 0, and when we look for our RA, that is reaction H at horizontal, we'll have something like this. That will be 800 cos 30. When I press my calculator to find 800, for my 800 cos 30, I get this is what I get. I get 692.8 Newton. Okay, and after that I go to the horizontal part. The horizontal part, I mean the vertical part, where it is 0. That is, this is the vertical part, upward and downward force. If you look at it, this one is showing a form of sign here, and that's why you have RA of vertical minus, looking at it, we have 45 here, at be 30 here. That will be 800 sin 30 minus this 400 that is here. That will be 400 plus RBV equals to 0. And when I press my calculator, this is what I'm going to have. I'm going to have something like this, and that will be minus 400 plus RBV equals to 0. That means RAV minus 800 plus RBV equals to 0. This means that RAV plus RBV equals to 800. Okay. Having this, I can take moment about point B. See, I want to take my moment now. Taking moment about point B. When I take moment about point B, see, everything about B will be 0. I won't even move closer to B. But what I will have now is all about A, and that's where That's where this comes in. You see, about A now, I'll be having REV now. This is my REV. My REV is acting downward here, and it will take everything here. And that's why I'll be having something like this until I get to this B side. When I get to B side, that's when it will stop. What I will have here, I will definitely have REV times 5, because R here is here, it's covering here, plus REV times 5 plus 400 minus that minus 800 sin 30 times 800 sin 30 times 800 sin 30 times 2, 800 sin 30 times 2. That's what I have here, plus 400 times 2. Okay, when I multiply all this together, I'm going to have something. Let me do it one by one so that we can get it. This one will give me 5 REV. It will give me 5 REV. All this one are equals to 0. Okay, 5 REV plus 400. This one will give me minus 400. And this one will give me, okay, minus 400 times 2. That will be 800 again. And this one will give me plus 800. Looking at this one will cancel this one. All equals to 0. 5 REV minus plus 400. All equals to 0. They are all equals to 0 here. And I will have 5 REV equals to minus 400. Divide through by 5. My REV, that is the RE at vertical, will be minus 80. And when I have minus 80 Newton, this is minus 80 Newton. Yeah, definitely this is my what? REV. To now get my RBV, don't forget this is REV. To get my what? My RBV, that we'll now go back to this equation here, that is let me say from equation 1 now. Equation 1, we have REV plus RBV equals to 800. And what is your REV? That's minus 80 plus RBV equals to 800. And RBV will be equals to 800 plus 80. Our RBV is 880 Newton. Okay, having gotten this, we can see we have our area of horizontal, which is 1, to be this and that. Okay, I can write everything. Therefore we have my RE horizontal to be what? 692.8 Newton. And that's my RH horizontal. And my RE vertical, that will be minus 80 Newton. And my RBV is here. This is my final answer for this.